Show that theta is equal to pi over 5 and theta is equal to 3 pi over 5 are solutions to the equation. Okay, so the first thing I'm going to do that is I'm just going to factor out a sine theta from here. So we're going to get that it's sine theta times 16 sine to the power 4 theta minus 20 sine squared theta plus 5 is equal to 0. So this tells us then that either sine theta is equal to 0 or 16 sine to the power 4 theta minus 20 sine squared theta plus 5 must equal to 0. One of these things must be true for either of these. So we know that sine pi over 5 does not equal 0. And also we know that sine 3 pi over 5 also does not equal 0. So therefore it must be the other ones, right? And so in order for these to be solutions, they must be solutions to, they must work to give us 0 for 16 sine to the power 4 theta minus 20 sine squared theta plus 5. Now keep in mind that in a previous section we learned that 16 sine to the power 4 theta minus 20 sine squared theta plus 5, this is the same as sine 5 theta. So it's possible then that sine 5 theta is equal to 0. So if we plug in the first one, which is theta equals pi over 5, we get sine 5 times pi over 5, which is equal to sine pi, and that is equal to 0, meaning that this one here is indeed a solution. And then we can make the same argument for the second one, pi or theta equals 3 pi over 5. So we're going to have sine 5 times 3 pi over 5, which is equal to sine 3 pi. And sine 3 pi also is 0, right? Because this is actually in the exact same spot as the sine pi, just one period length ahead, just 2 pi ahead of it. And so therefore that shows that both of these are solutions. All right, and the second part to this question asks us to show that sine pi over 5 times sine 3 pi over 5 is equal to root pi over 4. So what we're going to do here is we are going to use the quadratic formula on this second part. I'm going to highlight what we're going to use the quadratic formula on this part here. So in order to do that, we're going to say, well, therefore, sine squared theta is equal to negative b, so in this case 20, because negative 20 would be positive 20, plus or minus the square root of b squared, so negative 20 squared minus 4ac all over 2a, like that. So then that is going to give us 20 plus or minus the square root of 80 over 32. And then notice that 80 is the same thing as 5 times 16. So that's the same as 4 root 5. So we can say this is the same as 4 root 5. And then that way we can actually reduce this and get 5 plus or minus root 5 over 8. Now, if we want to find sine theta, we have to take the square root of that in order to find sine theta. So sine theta is equal to the square root of this whole thing. Now, what was the question asking us for again? The question wanted us to show that sine pi over 5 times sine 3 pi over 5 is equal to root 5 over 4. So now we need to multiply those things together. So if that's the case, that means we need to multiply both of these things by each other. So if we do that, we're going to end up with the square root of 5 plus or minus root 5 over 8 times the square root of 5 plus or minus root 5 over 8. And in this case, one of them is going to be plus, and one of them is going to be minus, so we have to multiply them. And that is going to give us root 20 over 64, which is the same as root 20 over root 64, which is the same as root 20 over 8. Now, root 20 over 8, if we remember that 5 times 4 is 20, that means 20 is the same as 2 root 5, so 2 root 5 over 8, which is the same as root 5 over 4 in the end. And now we have shown that, therefore, sine pi over 5 times sine 3 pi over 5 is equal to root 5 over 4.